right, so you guys look, we did the first one in class, right?
The first and the third we did.
The first and the third. So the second one, Kurt. And you just have to know those two equations. Okay? You have to know these two equations. The regular equation here. Make sure you know these two equations. If double, you can put anything you like. You can put 10, 20, 100, 200, 1, 2. Make life simple. Okay. Everybody good with this? And it should match exactly what you had for the exponential ones. In fact, I said go to those pages, take the equations off them. This way you weren't reinventing your wheel. Stop me if you have any questions. 3 we did. And this one I took from another one. Let's see, again, when your exponent is up, it has the variable in it. The only thing to get that down is that log rule, the power log. So you have to take the log of both sides. Do I need this one? Absolutely not. I put it there so that you would see the double part. This stays together, don't forget. And don't resolve it unless it can resolve and terminate. And it probably could. Divide by 4? Nope, maybe. Everybody good with this? Be careful with the parentheses. The 84s, you have the alpha P. The 83s, you don't. So be careful with your parentheses when you do these things. You're going to need a separate set of parentheses on the bottom in the denominator. Okay, again, and that might even work out with the terminating number. Nope, it doesn't. So if it doesn't terminate in here, keep it like this. Don't round until the very end. And rounding, 3 decimal places. If you're going to round in the interim, round to like 5 or 6 decimal places to keep yourself on the safe side. Okay. This part. Okay, this we're doubling. So our rate is here. This is where our rate goes. We're doubling in here. But we're not doubling every hour. That would be our time. We're doubling every 3 hours. So that's your cycle. That's in here. If it was every hour, it would be raised to the x. Every 3 hours, x divided by 3. You want to have it a cycle. You start with 2,500. You want to get to 100,000. You want to get to 100,000? Probably just forgot the 0. And divide it through. It divides nicely. Take the ln of both sides. Take the log of both sides. Switch them on and off, just to, so you'll see that you can do that. Bring down the x over 3. You don't have to do this. You could do it all at once. But I just multiply by 3 to get the fraction out of there so nobody panics on the fraction. And then divide by the ln 2. That was number 1. 15.966. This says hours. Kind of my scribble over there. By halfway through, you should be getting used to this handwriting. Good. Here's another one. This one's doubling. Here's your rate. You started with 20. You need to be 10,000. No cycle on this. Before, when we did this, we graphed it L1, L2. Solving it algebraically, you're going to use your logs, log of both sides. Bring down your x. Nice one, right?
I don't know why the x out of 12. Yeah, why would it be?
X out of 12?
Yeah, because it says every month.
Every month, right. So this is your unit over here. So when you end up, this is called months. The problem is this. If this was every month, and I gave you the number of years to stick into x, then you'd convert it to the 12. But whatever your label is, that's what that x value is. It could be days, it could be years, it could be centuries. Whatever that x is, You just label this part.
So how come it's like every 3 days that we put X over 3?
Because it's still days. It's still days. But it's not every day. This is every month. But it's not every day. It's every 3 days.
So it's every 3 days.
Then I would say X over 3, but you'd still have months. No 12. Everything doesn't have to be for a year. It could be whatever that denomination is. Seconds, it's time. It could be seconds, hours, days, years. It could be anything. As long as it stays the same through. Where you usually have a problem is where we plug it in ourselves and we said what will happen after 5 years. If I say what happens after 5 years, and this is my time, you have to take this and convert this to months. This is when you multiply it by 12. If this is every month, that stays months all the way through. Make sense? Okay. And the last one, it's a half-life, so your rate is a half. This half-life is every 14 days. Now, if it said the half-life is every day, then what would my exponent be? Just x. But every 14 days. So if it starts out with, say, 10 at the 0, at 14 days, it's going to be 5. At 28 days, it's going to be 2.5. That's what this cycle means. So I have to say divided by 14. Again, don't forget, this belongs to this only. So if you want to divide both sides by 6.58 and leave it 1 over 6.58, that's fine. If you want to do it this way, take the log of both sides. This is a product. This only goes to this guy, not to this one. So when we were multiplying life bases, we added the exponents, turn it into an add, and bring it down just in front of this one.
Why should we bring down X to 14 but then raise it to the 14?
No, I multiplied everything by 14 just to get rid of that fraction.
So you can divide by like 114?
Yeah. Yeah. I just figured let me get rid of the fraction because everybody hates to see fractions. Especially when you've got so much going on. Get this to one side. Just subtract it first. Get the subtract over there first. And you can divide by whatever you like, but you're going to have to divide by 1/14 and then the log of 1/2. Whatever you like, whichever way you like. I just got rid of the fraction. You can also do this one the way we did the other ones. It's not pretty, but you can divide both sides by 6.58. This is fine too. Then take the log of both sides. Just leave this like this. And work from there. That works too. This looks a little strange, so I did this one the long way. Just to show you, you can go either way you like. Just as long as you follow sound math rules, you're fine.